Right. If you're deep in your GCSE chemistry revision, you know that organic chemistry can feel, well, a bit overwhelming. But what if I told you there's a secret that makes it all click into place? Today, we're going to unlock a huge part of it, organic reactions.
So this is the big question, right? It feels like you have to memorize an endless list of reactions. But here's the thing, you don't have to. There's a pattern, a kind of chemical cheat code that once you spot it, the whole topic just opens up. And it's actually way simpler than you think.
And here it is. The secret is the functional group. This is the small, reactive part of a molecule that does all the heavy lifting. It's the part that determines pretty much all of its chemical behavior. So instead of learning about thousands of different molecules, you just need to get your head around a handful of these groups. Once you know how, say, a carbon-carbon double bond works, or what a hydroxyl group, that's the OH, does, you can predict reactions for entire families of compounds. It's a game changer.
So let's put this secret into practice. We're going to start by decoding the alkenes, then we'll investigate alcohols, and finally we'll master carboxylic acids. Make sure you stick around to the end because I've got the ultimate one-slide revision summary that pulls it all together. Let's dive in. First up, we've got the alkenes. You can kind of think of these as the energetic, slightly more reactive cousins in the hydrocarbon family. And their entire personality is defined by one thing, that all-important carbon-carbon double bond.
Now, what's so cool here is how everything on this slide links back to that double bond. The general formula, CnH2n, that's because the double bond means there are two fewer hydrogens than in an alkane. That's also why we call them unsaturated. They haven't been totally filled up or saturated with hydrogen atoms. They've still got room. And that C to C double bond, that's their functional group. That's where all the action happens.
See, that double bond is basically a hotspot of energy, just waiting to react. Think of it like a set of double doors ready to swing open and let something new in. That's why they undergo addition reactions. And look at the pattern, it's so consistent. Whether you're adding hydrogen to make an alkane or steam to make an alcohol, the alkene simply adds those new atoms across the double bond, which then snap shut into a single bond. It's a simple, predictable pattern, and it shows you the real power of understanding the functional group.
And speaking of that reaction with halogens, okay, listen up because this is a massive tip for your exam. The reaction with bromine is the definitive chemical test to see if a hydrocarbon is unsaturated. In other words, to check if it has a C equals C double bond. Trust me, examiners absolutely love this question.
And the test itself? It could not be simpler. You take your mystery substance, you add a few drops of orange bromine water, and you give it a good shake. If there's an alkene in there, it'll react with the bromine, using it all up. The result? That orange color just vanishes. It goes completely colorless. Easy marks, right? All right, let's switch gears and look at our next chemical family, the alcohols. These are some seriously versatile compounds, and all their power comes from their functional group, the OH, which we call the hydroxyl group.
And here we go again. You can see that pattern, can't you? A whole family of compounds, methanol, ethanol, propanol, butanol, they all behave in really similar ways. And that's because every single one of them has that OH group. It's that functional group that makes them so useful as solvents and fuels, and of course, it's what makes ethanol the star of the show in alcoholic drinks. So, what can this OH group do? Well, it gives alcohols a very distinct set of reactions. As you can see, they burn really cleanly, which makes them great fuels. They're also soluble in water. But I want you to pay special attention to that last one on the list, oxidation. The fact that an alcohol can be oxidized is a really key reaction because it creates a direct link to our next family of compounds. But before we move on, there is one specific process related to ethanol that you absolutely have to know for the exam, and that process is fermentation. Let's quickly nail down the details you need to remember. So, what is it? Honestly, it's pretty simple. You take yeast and you let it go to work on a sugar solution. The enzymes in the yeast convert that sugar into two things, ethanol and carbon dioxide. Now, the crucial part, and this is what you'll get asked about, are the conditions. First, it has to happen without oxygen. And second, you need an optimal temperature, usually around 37 degrees Celsius, to keep those yeast enzymes happy. Too hot and they break down, too cold and the reaction just grinds to a halt. And that oxidation of alcohols leads us perfectly to our third and final family for today, the carboxylic acids.
You can think of them as the next step up from an alcohol, and their functional group is the minus COOH group. And no surprise here, we've got another homologous series with a predictable naming pattern. You'll probably recognize ethanoic acid. That's the main component of vinegar. And as the name suggests, their key property is that they are acids. But, and this is a really important distinction, they are weak acids. And because they're acids, they do all the typical acid things. For example, if you react them with a metal carbonate, you'll see fizzing as carbon dioxide is given off. That's a classic test for any acid. But check out that second reaction. They react with alcohols. This is where it all starts to come together, right? You've got these different families, each defined by their own functional group, interacting with each other. It's pretty cool.
Now, for all you higher tier students out there, it's really important you understand what we actually mean by a weak acid. Think of it like this. A strong acid, like hydrochloric acid, jumps into water and releases all of its hydrogen ions at once. But a weak acid, like ethanoic acid, is a bit more cautious. It only partially ionizes, meaning it only lets go of some of its hydrogen ions. This means there are fewer H+ ions floating around, which results in a higher pH for the same concentration. So, the key takeaway, weak means partial ionization. Got it?
Okay, we have covered a lot of ground there. Pretty quickly, we've looked at 3 huge organic families. So let's pull all of that essential information together into a single powerful revision slide. Okay, here it is. This table is your key. For each family, you just need to link its name to its functional group, to an example, and to a key reaction. Alkenes with their C double bond decolorize bromine water. Alcohols with their minus OH group can be oxidized to form carboxylic acids, and those carboxylic acids with their minus COOH group will react with carbonates to give off CO2. If you can master this table, you've mastered the core of this topic. You know, when you boil it all down, what we've really been doing here is learning a new language. The functional groups are like the key words, and the reactions are the grammar. And once you understand that simple grammar, you can start to read the chemical world and even predict what's going to happen next. So, I'll leave you with a final thought to chew on. We saw that alcohols and carboxylic acids can react together. Now that you know their functional groups, the OH and the COOH, what kind of new molecule do you think they might form when they come together? And what small molecule do you think might get kicked out in the process? Have a think about that. Thanks for joining me.